So this question, which is question 2 from the EE GATE 2020 paper, asks us which of the following statements are true for all possible non-zero choices of integers or real number constants, arbitrary constants, as given. Underneath the question, you will find the relevant NPTEL video title for this question. The background that you will need for this question are the following integral formulae, limit formulae, and the trigonometric formula. So let us go over these options one by one and see which of them are true and which are false. So option A is actually false, and it can be shown for this particular value of m and n. So why does option A become false if it fails for a single m and n? Remember that the question says all possible non-zero choices of the constants, right? So even if I find one that fails, then the option is false. And in this case, I have, so for m equal to 1 and n equal to -1, it becomes sine theta into sine of minus theta, which is integral of sine square theta. And since we know that the integral is the area under the curve, and that sine square theta has a graph which sort of looks like that, that is, it's completely positive, so the area has to be positive over any interval on the x-axis that is non-zero length. This has to not be equal to 0, and therefore this option is false. Thus A is false. And similarly, you can see that B would also be false by putting P equal to 1 and Q equal to -1 or vice versa. So I'm not going to go into that any further, right? So let's look at C. So for P not equal to Q, we can expand sine theta and cos theta as follows, which is like that. And then, of course, we bring the 2 outside and we separate the integrals by linearity, and then we integrate the internal expression, which gets which becomes minus cos p plus q by p plus theta by p plus q, and minus cos p minus q theta by p minus q. And then applying the limits of the integration, we would just get pi here, theta equal to pi here, and theta equal to minus pi here, right? Which if you expand it, you will find that that is also equal to 0. And thus option C is correct. So we find our first true option. And in option D, we can proceed similarly to option C. Expand sine theta and P into Q. We again say P not equal to Q. And then we proceed as we did before, right? Except this time we would be getting sine theta into sine p theta into sine q theta, and so the expansion is a little different, but the philosophy is the same. You would just go ahead and apply the limits after you integrate, and once you apply the limit, you can see that this reduces to an expression of the form sine a alpha by alpha, and then you have some constants similarly on, so as for both of the sum terms, and this is a standard limit which both go to 0, right? So thus option D is also correct. So yes, this is a 1 mark question where either if you chose option C or option D, you would get 1 mark for it.